Okay, today in previous video we have already proved two properties of beta function. Now in this lesson let us prove remaining two properties. That is, the first property is b of mn is equal to b of m plus 1 comma n plus b of m comma n plus 1. The second property is if m and n are positive integers, then we have to prove that b of mn is equal to m minus 1 factorial n minus 1 factorial m plus n minus 1 factorial. Okay, now let us start with the first problem. Okay, now as per the definition of beta function, we have b of mn is equal to integral within limit 0 to 1 x power of m minus 1 1 minus x power of n minus 1 dx. Let us take RHS. There is b of m plus 1 comma n plus b of m comma n plus 1. Now as per the definition of b of mn, we have b of m plus 1 comma n is equal to integral with the limit 0 to 1 x power of m 1 minus x power of n minus 1. Okay, because here similarly b of m comma n plus 1 is integral with the limits 0 to 1 x power of m minus 1 1 minus x power of n dx. Okay, now this is a current integral with the limit 0 to 1 x power of m 1 minus x power of n minus 1 plus x power of m minus 1 1 minus x power of n dx. That is why I consider a single integration. Okay, now we can write down x power of m as x power of m minus 1 into x into 1 minus x power of n minus 1 plus x power of m minus 1. I can write down 1 minus x power of n as 1 minus x power of n minus 1 into 1 minus x dx. Okay, let us take x power of m minus 1 x power of m minus 1 into 1 minus x power of n minus 1 x power of m minus 1 into 1 minus x power of n minus 1 as common. That is integral within limit 0 to 1 x power of m minus 1 into 1 minus x power of n minus 1. Then we have x into x plus here 1 minus x, because we already taken these functions as common. Therefore x is remain here 1 minus x remains. Therefore integral with the limit 0 to 1 x power of m minus 1 into 1 minus x power of n minus 1 x plus 1 minus x minus x cancelled. Therefore 1 into 1, that is into dx. Therefore this is clearly b of mn. Therefore b of mn is equal to b of m plus 1 comma n plus b of m comma n plus 1. First, third property is proved. Now let us prove this property. Okay, by the definition of beta function, we have b of mn is equal to integral within limit 0 to 1 x power of m minus 1 1 minus x power of n minus 1 dx. Okay, now let us integrate this as by parts, integration by parts. Okay, integration by parts formula is integral u dv is equal to uv minus integral v du. Therefore, here in this integration we have to consider one function as u and another function as v. Okay, let us consider x power of m minus 1 as u, that is u is equal to x power of m minus 1. Another function 1 minus x and minus power of n minus 1 dx as v dv, that is dv is equal to 1 minus x power of n minus 1 dx. Integrating on both sides, 1 minus x power of n minus 1 dx, we get v is equal to minus of 1 minus x n minus 1 plus 1 by n minus 1 plus 1, that is v is equal to 1 minus x power of minus 1 cancel power of n by minus 1 plus 1 cancel by n minus, this is v. Therefore it is u, it is v. Okay, let us substitute these two values in integration by parts formula. Then we get b of mn is equal to, okay, first u, as per the formula uv, u is x power of m minus 1 m minus 1, v is 1 minus x power of n by minus n within limits 0 to 1. Okay, as per the formula minus integral with the limit 0 to 1 v du, v means 1 minus, v means 1 minus x power of n by minus n, derivative of u, derivative of u, derivative of u is m minus 1 into x power of m minus 1 minus 1 m minus 2 m minus 2 dx. Okay, now after applying the limits, this term will become 0, because if we replace x with 1, we get 1 minus 1 power of n, that is 0 power of n, 0 into this function will become 0. Similarly, minus of, if we replace x with 0, then 0 power of m minus 1 into this function, this will also become 0, and totally the function in this box bracket is totally become 0. Now therefore minus into minus plus, integral 0 to 1, here m minus 1 is constant, n is constant, therefore m minus 1 by n, okay, x power of m minus 2 1 minus x power of n 1 minus x power of n dx. Okay, we can write down this function in the beta function form, that is m minus 1 by n into integral with the limit 0 to 1, here m minus 1 m minus 1 minus 1 m minus 1 minus 1 into 1 minus x n plus 1 minus 1, n plus 1 minus 1 is n, therefore n plus 1 minus 1 into dx. Clearly it is m minus 1 by n into b of m minus 1 comma n plus 1. Okay, this is b of mn. Now let us find this function, this value, that is b of m minus 1 comma n plus 1. Okay, let us consider this equation by one. Okay, now to get this value, it is enough to replace m with m minus 1, n with n plus 1, because already we have found it. Okay, now replace m with m minus 1, n with n plus 1 in 1, then we get b of m minus 1 n plus 1 is equal to, we have replaced m with m minus 1, n is replaced by n plus 1, therefore m is replaced by m minus 1, therefore m minus 1 minus 1 by n is replaced by n plus 1, n plus 1 into m is replaced by m minus 1, m minus 1 minus 1 comma n is replaced by n plus 1, n plus 1 plus 1. Therefore b of m minus 1 comma n plus 1 is equal to m minus 1 minus 1, m minus 2 by n plus 1, m minus 1 minus 1, m minus 2 comma n plus 2. Now replacing this value in equation number 1, that is in place of b of m minus 1 n plus 1, replace with m minus 2 n plus 1, m minus 2 and n plus 2, we get b of mn is equal to m minus 1 by n, m minus 1 by n into b of m minus 1 n plus 1, b of m minus 1 n plus 1, its value is m minus 2 into n plus 1, m minus 2 comma n plus 2. Okay, therefore we continue this expression as m minus 2 n plus 1, in this way m minus 1, m minus 2, m minus 3, n plus 1, n plus 2, here m minus 3 comma n plus 3. Okay, proceeding like this, we get b of mn is equal to m minus 1 into m minus 2 into m minus 3 into and so on, m minus up to m minus 1, m minus 1 by n into n plus 1 into n plus 2 into n plus m minus 2. Here is m minus 1, here is m minus 2, m minus 2 minus of m minus 1 plus m minus 2, like this. Here is m minus 3, 3 is here, 3 minus 1, 2 is here. Similarly, m minus 1 is here, m minus 1 minus 1, that is m minus 2 is here. Okay, m minus 3, n plus 3 minus n plus 3 minus 1, that is 2. Here also m minus 1, n plus m minus 1 minus 1, that is m minus 2, b of m minus 1 comma n plus n minus 1, n minus 1. Okay, here is m minus 3, n plus 3, in place of 3 here is m minus 1, m minus 3, n plus 3, that is m minus 1 comma n plus n minus 1. Okay, here m minus m minus 1, m minus m minus m cancelled, minus and minus plus 1, this value is 1, this value is also 1, therefore replace it with 1. Okay, let us assume this as 4. Okay, now this value is, that is b of 1 of n plus m minus 1 is, as per the beta function, integral with the limit 0 to 1. Here 1 means x power of 0, x power of 1 minus 1, x power of 1 minus 1, it is 1, x power of 0, 1 minus x power of 1 minus x power of n plus m minus 1, n plus m minus 1, n plus m minus 1 minus 1. Therefore it is 1 minus x power of n plus m minus 2. Okay, that is here. Check here, x power of 0 means x power of 1 minus 1, 1 minus x power of n plus m minus 1 minus 1. Therefore 1 minus 1 1. Similarly in this power, n plus m minus 1 minus 1, n plus m minus 1, n plus m minus 1. Okay, now its integration is, integral value is 0 to 1, 1 minus x power of n plus m minus 1. By solving this integration we get 1 by n plus m minus 1. Okay, therefore b of mn is equal to, from 4 b of mn is equal to m minus 1 into m minus 2 into m minus 3 into and so on 1 by n into n plus 1 into n plus 2 into n plus m minus 2, and this value is 1 by n plus m minus 1. This value is 1 by n plus m minus 1. Okay, now m minus 1 into m minus 2 into m minus 3 into and so on up to 1 into 2 into 3 into m minus 3 into m minus 2 into m minus 1. This will become m minus 1 whole factorial by n plus m minus 1, n plus m minus 1, n plus m minus 2 and so on, n plus 2 into n plus 1 into n. Okay, now by multiplying the numerator and denominator by n minus 1 whole factorial, we get m minus 1 factorial into n minus 1 factorial, n plus m minus 1 into n plus m minus 2 into and so on, n plus 2 into n plus 1 into n into n minus 1 factorial, because we multiply and divide with n minus 1 whole factorial, numerator and denominator. Therefore this is simply m minus 1 whole factorial, n minus 1 whole factorial by, all of this become n plus m minus 1 whole factorial. It is because n minus 1 factorial means 1 into 2 into and so on, n minus 1 into n plus 1 into n plus 2 into and so on up to n plus m minus 1. Okay, but this means This means 1 into 2 into and so on up to n plus m minus 1 means n plus m minus 1 whole factorial. Okay.